Okay, this is 8-4 special right triangles, objective 5. In my opinion, this is the single most important section of the entire geometry year. So it's very important, the concept that you learn in this section. And you will use again and again and again going forward in the math courses that you take in the future. Okay? Alright, so you can do this one, right? I'm just going to write the answer here, so you just try to get there. Okay? And this is 3 root 2 over 2. Okay? Make sure you can do these. You got to be able to solve these very fluidly to be able to do this section. Okay? So objective 5 is determine the length of the determine the length of two sides of a 45, 45, 90 or a 30, 60, 90 triangles. These are right triangles because there's 90 degrees, so it's just right triangles. When the length of the third side is known. Okay, so you know that this is a special kind. These are two special kind of right triangles. And if you know one length and you know that they are special kind of triangles, you know the two other lengths. Okay. All right. So here's the two theorems. If we have, this is isosceles right triangles, right? 45 and 45. This is right triangle. If it's isosceles right triangles, the 45, 45, 90 triangle, the length of the hypotenuse is root 2 the length of the leg. Okay. Let the side of the given triangle A, and C, apply the Pythagorean theorem to solve C. Okay, so if you do A square plus A square have to be C square, right? So you have 2A square equal C square, and A is the length of the leg. So you take the square root of both sides, you get square root of 2A square equals C, right? It's plus minus, but it's a length, so we just stick with plus. Okay, but when you do in algebra 2, take a square root of both sides, don't forget to put plus minus. So A, there are two A's, so A is going to come out, root 2 and C, right? So the length of the C is the length of A times root 2. That's what this is, okay? Length of the C is root 2 times the length of A. Okay, so you should do this. You know that this is, if this is 45, then this is 45. You know this is special right triangle. You know this is 12, then this length is 12 root 2, right? And this one, so now this is C, right? The hypotenuse is C, and this is X. So root 2x is 8, right? Length of the leg times root 2 is the hypotenuse. So x is 8 over root 2. So this is 2 over 8 root 2. This cancels 4 root 2. Okay. I just rationalized here. I skipped a step, but hopefully you know what you're doing at this point. So that's how and then I'm going to go over this one first, and I'm just going to go a little bit of insight into hopefully which strategy to use for different problems. Okay, so this one is the other special right triangle. There is a 30, 60, and 90 triangle. This is the most important triangle in any math. It comes out again and again and again. Okay, so if this is a 30, 60, and 90 triangle, the length of the hypotenuse is 2 times the shoulder leg. Shoulder leg is across the 30. 2 times the shorter leg, and root 3 times the longer leg, root 3 times longer leg. So the ratio of these lengths is 2 to 1 to the root 3. Okay, if the short leg is 1, the hypotenuse is 2. Okay, and longer leg, if I'm sorry, the longer leg is root 3 the shorter leg. Okay, so hypotenuse is 2 times the short leg, the longer leg is root 3 times the shorter leg. Okay, so the ratio is, you remember this 1, 2, 3, but you know the square of the 2 is 4. Square of root of 3, if you square, this is 3, so this is longer, right? Even though the 3 is a bigger number, 2 is a 3 inside is a bigger number, 2 is bigger than the square root of 3. So it's 1, 2, 3, but the 2 is the hypotenuse. That's how you remember it. And the proof of this is that if you put another right triangle here that is a 30 and 60, you get the equilateral triangle, right? So this C is equal to 2A, right? Because it's the same length. C is 2A, and that's why this is half. Hypotenuse is half of short leg. So that's easy to remember. If you put the other one here, hypotenuse is the same length. That's the half. Okay, and then if you know this is 1 and this is 2, you can solve Pythagorean theorem to get to root 3. That's how this proof is. Okay, so for this problem, you know the short leg is 6. So hypotenuse is 12. You just do times 2. Okay, and then y is 6 root 3. 6 times root 3. So when you know the short leg, it's easy. Okay, now this one, you have to change this to short leg and then multiply by 2 to get y. Okay, so root 3x is 8, right? The root 3 times short leg is 8. So x, the short leg, is 8 over root 3. In the process of calculating, well, you have to solve for x, so yeah, you have to rationalize. Okay, so this is 3 over 8 root 3, and that's x. So y is 2 times that, so 16 root 3 over 3. This doesn't cancel, so that's it. Okay, all right. So what I want to point out here is that, is there space here? Okay, let's use this space. So far, it's important here. So far in 8.1 we did geometric mean, right? And this one is the one that you have altitude, and then you know like you know this length, or this length, or this length, or this length, or this length. One of these are missing, and then you can, or actually, if you need to know 3 of these, and then the other 3 you can come up with it. That's geometric mean. 8.2 was Pythagorean theorem. This one is when you have a right triangle, right? So this is a right triangle, so it's one angle, right? And for you to use Pythagorean, you need to know the 2 sides, either this and this, then you can find this and this, you can find this, and so forth. You are missing only one leg, missing one leg length. Because, in a way, this is, it's a hypotenuse. If you, in right triangle, if you know 2 sides, you know the triangles are congruent, because it's either hypotenuse leg, 2 sides and an angle, or side, angle, side, right? Hypotenuse leg, or side, angle, side. So if you know the 2 sides plus right angle, you know the triangles are congruent. That's why you can find the missing lengths in this problem. Okay, now 8.3 was the converse. This is A4. A3 is a little different, so it's just A4. This is special right triangle. Okay, in this case, what happens is there is a right triangle, right? You have a right triangle, and you know the other angle, one way or the other. they either give it to you, like say this is 60, or you know that this is right triangle. I mean, equilateral triangle, so you have to know that this is 60. Or there are many other ways that for you to figure out that this is 60, but you know two angles. So if you know two angles, you only need to know one more angle because it's angle, angle, side. One more side because it's angle, angle, side. So you just have to know one side, then you know the other side, because that will make the triangles congruent. Angle, angle, side, angle, angle, side, or angle, angle, side. So if you know the two sides and trying to find the third, the missing length, it's Pythagorean. If you know the right triangle and then another angle and then one side, and you have to find two other sides, that's special right triangles. Okay? And the geometric mean is when you need to know these separate lengths. Okay? Hopefully this kind of helps. But when we do the review, this becomes a little bit clearer for you, hopefully. Okay? Alright, so let's do some problems. I think these are not bad except maybe this one. So I want you to do odds here. Odds for homework. I don't think we need to do any of them right now. And we have 3 more problems. So let's do these, okay? And then we do the exercise in the class. Okay, so this is in a regular hexagon, AB is 8, and find AD and AC. So you get a lot of hexagon problems because hexagon is a collection of equilateral triangles, okay? Because there are 6 of these vertices, right? If you divide by 6, 360 by 6, each of these is 60 degrees, right? And these are regular polygons, and these are all same lengths because this is center of the hexagon. So if this is 60 degree and these are isosceles, this should be 60 degrees. So these are all equilateral triangles. So you will get a lot of hexagon problems in many different part of the rest of this textbook. Okay, so knowing that these are hexagons and equilateral triangles, these are all 8, right? It's regular hexagon, but this is also 8, and that's also 8. Okay, can you see that? This is 8 and this is 8. So AD is 16. Okay, now how do we get AC? So AC is this, right? And that's not a right triangle. However, do you remember what the internal angle of a hexagon is? Yeah, it's 120. So this is 120 right here. Each of these is 120. So if and this is isosceles triangle, right? So it's 8 and 8. So if I do an angle bisector here, this is going to be 90 degree, right? And then this, because it was 120, one of these is 60, right? Choose is 60. It's so small, but this angle bisector of this CBA angle is going to be 60. So if I take this triangle out here, so this is C and A, and this is 8. This is 60 degree, and this is 90 degree. If it's a right triangle and then you know the two angles, and then it's a special triangle, and then you know one side, you know the other two sides. Okay, so hypotenuse is 8, so short leg should be 4, right? So then the long leg is 4 root 3. And then you have 2 of these, so AC is 8 root 3. You see how difficult it gets quickly, this section? This was an easy problem. Alright, let's look at 11. Express PQ, PS, and QR in terms of A. Okay, so this probably is not as bad. This is 30 and 90, and this is 60. This is the short leg, long leg, and hypotenuse. So in terms of A, so in terms of short leg, PQ PQ is 2a, right? And PS is root 3a. And QR, so this is hypotenuse is root 2a. This was easy. Wow. Look at the difference in difficulty between 10 and 11. Okay, and 12. If the measures of the angles of a triangle are in ratio of 1, 2, and 3, are the lengths of the sides in the same ratio? Explain. Okay. So 1, 2, and 3 is, for example, 30, 60, and 90 is 1, 2, and 3, right? I think that's the only ratio that you have this in a triangle. And the length of the side is 1 to root 3 to 2. So it's not the same ratio. So no. Okay. Alright, so you're doing alls for these problems, and then I will assign some problem for the survey. Okay?